Right now, I'm really happy as well to have our next speaker who is already waiting with his presentation. Once again, guys, I want you to give applause if you could. I think we are just saying this theoretically. So, Emma, thank you so much for joining us. Emanuel Suriano today, the senior software engineer at OMIO. Uh,
Yeah, that's true.
am I correct?
Yeah.
Is it do you prefer so people would call you Emma, or how is it better?
Yeah, exactly. So Emma is shorter. I come from Argentina. So in Spanish is Emmanuel and in English is Emmanuel. So it's confusing for me sometimes when people call to me. So
Uh,
then shorter and easier version is Emma.
so please welcome Emma Soriano with his speech. He's going to talk about TypeScript runtime validation. So the floor is yours, Emma.
Sure. So I'm going to present the screen. Cool. So hello everybody and welcome to my talk. The name is Runtime Temp Validation in TypeScript for React Global Online Summit 2020. But first, let me present myself. So hello there, I'm Emma Soriano. I'm a web developer. I'm also an open source enthusiast. I'm a maintainer of some open source project. I'm also contributing some other organizations such as Gatsby or Next.js too. Then I'm a writer in my free time. I have a tech blog and I also have a personal blog where I write about anything that normal. Recently, I've been writing about Corona, for example. So it's not only techie. And then I'm also a foodie and a cook, which goes very well together. And then lastly, I love to travel. Like the pictures there is myself there in Thailand. Was the best trip I made in my life. I'm hoping to come back, but sadly, well, we can't right now. And I hope that you all guys are safe at home. So let's start with the presentation. So I've been working with TypeScript for more or less 2 years, maybe 3 now. And I discovered, or I would like to quote what people normally say when they're working with TypeScript. And yeah, they're quite opinionated. So the first one is, my application is fully typed, is 100% bug free. And people basically assume that by using TypeScript, there won't be any bugs on it. The next one is, we're using TypeScript. There is no need to test, which is pretty funny because yeah, it doesn't replace the test, but still people are thinking, yeah, it's a way to test our application by writing them types. And then the last one, which is amazing, if it builds, it works in production. So we won't see any crashes. We won't everything will happen smooth and it will work. So my face after I hear this is like, oh my God, why we are doing this, guys? So here's a quick way to show why I'm saying that. So let's go with a very small snippet code. So here I have one type of definition. In this case, it's this example type, which has required property name, which is a string, an optional property with age, number, and then we have an array of pets. Each one has a name and legs, right? Name and pets are required properties, so ideally they should always exist in the type. Then we have a function, fetch data, which ideally will fetch some data from an external API, and then we'll return, as we say here, the promise will have the structure of our example type. Then here we have a function called getBy, which is an async one, and it's going to call fetch data. But then the problem that we're seeing here is that the backend is returning to us only the object with the name property, and there is no pets inside, no array. So then the next step, what we are doing is we're assuming that pets is always there, and then we are just looking for the pets with 2 legs, and the application will crash because pets is undefined and find doesn't exist in undefined. So yeah, basically what this means is TypeScript performs static type checking, but then runtime validations are outside the scope. So many people assume that TypeScript will check the types, and TypeScript is just compilation time, and in your final application, it wouldn't even exist. So we are the ones that need to take care of the runtime validation, not the framework itself, because it's not built for that. So the question is, do I need to validate everything? Because it means that if TypeScript wouldn't take care of that, then I have to. And the simple answer is no, luckily. And there is an easy way to distinguish what do we really want, what do we really have to validate and what we don't. So it's validate all the external sources of your application. So by external sources, I mean stuff or data or whatever kind of structure is coming to your application that you don't have control on it. So some examples are API responses, as we saw from before. We can type all the API responses that we want to. We can be using some GraphQL generator, whatever, but if the backend at the end is not responding the proper response in runtime, and then we are not checking in the clients, it will most probably crash, because we are going to assume that something will exist when it doesn't. The other one is content from files. In many situations, sometimes we have to read from files, expecting that there is some kind of a special structure, can be a JSON, can be a YAML, can be everything. And yeah, we have to validate if this structure is the one that we are expecting for. And then the last one is untyped libraries. So when we are working with TypeScript and we're using a library, sometimes this library doesn't come with the specific types inside. So in case this is not happening, so then we should always validate that the response of a function or some helper that we're using is exactly what are we expecting. This ideally is to not have crashes or to prevent bugs in the end, right? So let's check some commonly used approaches to do these validations. So the first one is a manual validation, and I think that we are mostly used to it. It's a set of conditions that check if the structure is expected. And this will sound complicated, but it's actually pretty straightforward, and I think that we all do this. So let's go back to the previous example. We have our getBy function, and then here we are introducing a validate function, right? That will receive the data coming from the fetch data function, and in case that is not valid, then it's going to throw an error. So what is this validate function? It's pretty simple. It's just a set of ifs. It's something that we are all used to do it. So I'm asking, like, if pets actually exist in data. If it doesn't exist, I'm returning false, because this is not a valid structure for me. If here we can add any other checks that we want to do, we can add more complicated logic. For the sake of the presentation, I wanted to keep it simple. And then in everything is cool, then we just return true. And then at the end, we can finally perform our find, and ideally, it shouldn't crash. Just one thing, as you can see here, I'm just asking if pets exist, and we can actually check for the length. We can actually check for the structure inside the pets. There is a lot of things that we can do here. But again, this is custom logic that we are writing down. So some pros about it is, well, there is no external library required, which is write vanilla JavaScript, vanilla TypeScript, and it will work. And then the other thing is we can actually add some business focused logic. What I mean with that is, like, let's say that we have two properties that are linked in some way. Let's say that one object has the IDs in another array. We can add a logic inside our function, which is in the end pretty cool. I mean, it's going to be more advanced in order to maintain it, because now we are introducing a lot of dependencies inside, but we have the possibility to do it there, because basically it's a custom function that we can do whatever we want. The cons are, well, first of all, there is a lot of manual work involved. Basically, every condition that we add, let's say that we add business focus conditions, is something that we need to add. And then in the end, also, we're going to end up adding a lot of duplication of code. Why I say there is duplication of code? Because in our type, we're going to say that pets, it's an array which has to be always there, which is required. And then in our function, in our set of ifs, we're going to say, oh, pets has to be there. So that's a duplication of code that I'm mentioning. So let's jump into the next one. The next one is the commonly used, I will say, in case we want to tackle this in a proper way, which is using a validation library. And in summary, is make use of any existing validation library to check for the structure of the object. So some examples that are currently being used by the community are AGV, Joy, V8N, validate.js, just some examples that I found out on the web. So most of them have the same concept. We need to create some kind of schema or structure that then we run through these libraries, and then will return us some function that we can finally use to validate our objects. That's the whole concept. The main difference between them are basically the syntax or maybe the extensibility that they have inside. But the whole idea is that, for the sake of this presentation, I'm going to be focused on AGV, but this concept will apply to any of them. So let's start with it. So this is, here we have our code. Here at the top, we are importing AGV, and we are creating our new instance. And this is the schema that I was mentioning before. So here we need to define the schema of the objects that we want to validate. In the example from below, just to recap, we have a name property, which is a string and is required. As you can see here, we have the property name, which is type of string, and as using some kind of library, validation library, we can enhance the validations, but setting some more conditions on top. Also, as you can see here, we have the array of required properties, and name is here. Then we have age, which is a type number, but then it's not required, as we wanted to keep it exactly more or less similar to what we have in our types of TypeScript. And then we have pets, which is an array. Each item is going to have these properties, and then is going to have the legs. So then we are going to, coming back to the same example of getBy function, we are going to fetch the data. But now we're going to call validate. This validate function, again, comes from here, which is a function that we compile with our schema. And here is the main difference with the previous example. So now, in case this fails, we have the power of get the proper error handlings from the validate function. So this is something special about AGV, but most of the other validation libraries will provide some kind of way to know, okay, what was wrong, right? So the way it works is AGV provides this helper, error text, and then validate is the function that we use, and every time we call it, it's going to modify these property errors, and it's going to store all the errors there. So in the end, this is going to output this following message: error, validation failed, data should have required property pets, which is way friendlier. And in case we are doing some kind of debugging in production, or we want to know what went wrong, this is pretty helpful to have. In the previous example, we were just returning true or false, and we were just saying, okay, this is an invalid structure. And it's quite annoying when you have to debug something. So pros. The pros about this way is that we have finally a standardized way to create validators and checks. And what I mean with this, so first of all, we have a way to create this schema. Then this schema is has a special way to say, okay, here's how you define a property. This property has a specific type. And also we can say, okay, a string can have a minimum length of 3. In the previous example with the if, with the manual validation, we can check the length of, for example, an array in several ways. We can check for the length, then we can iterate over it. Like it's a mess. So this is a good thing that we have only one or two ways to do one thing and not the whole JavaScript umbrella of possibilities. And then the other one is that we have a huge improvement of error reporting, because now the error reporting is basically handled by the framework, and we don't need to do it by ourselves. But what are the cons? So the cons is we're introducing a new syntax to the project, which is, I would say, something not that good. It will obviously increase the complexity of the project, because now every developer that wants to jump into the project and create some kind of validator, they need to know about AGV. And for that, they need to go to the documentation. And every time we add a new syntax, this will happen. And yes, I will say it's a cons that everybody should consider. And then the other one is validators and types are not in sync. So when I was defining my schema, I wrote it down manually. Like I said that, okay, I have a property name, which is required, it has a string, it has a minimal length of 3. So still we have some duplication of work. And here I decided to put a storable, because there is some open source projects out there. Then what they do is like, well, you define your AGV validator, and from there they generate the Typescript types, which kind of work if you think about it, but still the introduction of a new syntax is there, and then you end up having dynamic Typescript types, which can be even more confusing for newcomers on the project. But the purpose of this talk, and this is why I name, I want to introduce you this alternative way of creating validators, which is dynamic types validator. And here we are going to create validators from your types. So let's see how it was before. So before we had a validator and the type. Both are kind of separated. And then from there, we are going to receive an object. And then the validator is going to take the object and then apply the type. And then after that is going to return the validated type object. So with that object, we are 100% sure that we can go on with our application flow. But again, the validator and types are two different entities and they're separated. But now the type is going to remain the same, but it's going to generate the validator for us. Then with that validator, we're going to validate the objects. And finally, we're going to have the validated type object. So we have now an unidirectional flow to validate our objects, and everything is in sync. We don't have anymore the problem from before. So I want to introduce to this new library. It's called Typescript JSON Validator. And the description or the title of this is automatically generate a validator using JSON schema and AGV for any Typescript type. And I didn't make it. It was made by Forbes. So I want to say publicly huge shout out to him. It's an amazing library. And I think more people should know about it. So how does it work? Let's say, again, we have our lovely example type, super simple. Name require, age optional, pets array require. And then so this library is actually a CLI, which we just need to call it. We can call it with npx, we can install it and call it with yarn, but it doesn't matter at this point. We just need to specify which is the type and then the name of the type. And then after that is going to create our validator for us, given this type. So this is the result. And there is a lot of boilerplate involved because of a lot of default values. There is no need to look at the whole code. I'm going to just provide a big overview. So in summary, here we are creating the instance of AGV with some default values. Then after that, here, and this is the sweet point of the framework or of the CLI, is going to generate the whole schema that we have from before for us. It's automatically, it will read the types. So for example, here we have name, which is a type string, age type number. Then we have the pets that we saw from before. And here we have the required properties. It's more or less the same as I did before, but now it's automatic, which is amazing. And then it's going to create this type validate function, but the most important part is this function is example type. which is going to compile with AGB, exactly the same as we did with our schema. And then the last part is going to export the function validate, which is going to receive a value unknown. And by the way, this should have been the proper type when we receive the data from the backend, because we actually don't know the type, it's unknown. But then it's going to say, okay, I'm going to return you an example type. And now it's 100% sure because I'm running it through AGB. So here is going to say, oh, it's example type. And again, this is going to use the compile function that we use from the schema. If that's the case, return value. If it's not, then it's going to throw the error. And this is something that we saw from before. It's basically using the same function, errors text, that we saw from before. So it's going to output the whole description of what's going on or why did it fail, which is pretty nice. And again, this is all automatically generated for us. So the final implementation, basically, we just need to import a function. And then, well, this is the code in the end, which is, the difference I did here is just I call the await, fetch data here, and then I'm basically sending it to validate. Another cool thing to just see is that now the code looks very synchronous, because the if checking if there was some errors is actually inside the validate function. And then, yeah, at this point, data is for sure example type, for sure. And then we can just continue with the normal flow. So another thing that I want to highlight about this library is these generators are based on AGB. So then we can use the power of AGB inside our types. And this is how we do it. So we can create some kind of comment annotations, which are not going to break our types for sure, because in the end, for Typescript, they're just comments and they're not going to be transpiled, which then we can say that, for example, email is an optional string, but it has to have the format email. An answer is a required number, but it has to have a minimum number of 0. It has to be in the range between 0 and 100. And then when we compile it, this is the schema that we have in the end, which is pretty neat. So in the end, we are combining the power of the two. So we have like some kind of extended code, let's say. So we have part Typescript, and then in case we want to be more specific, in case here we want to validate the format of a string, we can do it by using the specific settings of AGB. For this, sadly, we just need to check it out on the AGB website. But again, this is in case we want to, it's not required. But wait for a second, because there is something that I didn't mention yet. Every time I'm showing an example, I basically run in the CLI in the command line. I'm saying, okay, create a validator for this file, and then give me this validator. And then, okay, what happens if I want to create, well, several validators? What happens if I change validator? Do I need to rerun it again? So, yes, you are right. It's basically, that's one of the drawbacks that I saw of the library. You need to run it manually. But I kind of hack around it, and I realized that there is a way to do it. So in the end, our application is totally dependent on the validators. So before starting the application, we always need to make sure that the validators are there. One way is to run it manually, each type once. It's going to be a lot of work, or we can create like a very long script. But what if we automatize it in some way? And for that, I just want to give you one of the best solutions that I found is using the pre-commands of NPM. So pre-commands are part of lifecycle scripts of NPM, which allows you to run a script before another one. So the way that you define them is, let's say that we are working in a React code base. So then we have start and build, right? So here we are going to say, oh, pre-start. On pre-start, I want to generate my validators in this folder. By the way, we are going to see this file soon. But just imagine that this file basically is going to grab all the types inside this folder and generate the validators. Once that is done, then we are going to start our application. The same for the build. So in this situation, we are 100% sure that the validators are going to be there. And when we execute yarn start, for example, we are going to see that first it's executing the it's generating the validators for everything that I have there, and then it's running React scripts. So problem of how to create all the validators at the same time is kind of solved. Let's see a basic implementation of this script. Again, there is, I will just give you a huge, it's not that long, but it's going to be an overview of it. So the first one is I'm reading the directory, sending the arguments. I'm checking if it's a directory, otherwise please specify a directory. It doesn't make sense to continue the execution. After that, I'm reading all the types, and I'm avoiding all the validators files. And with that, I'm just taking the name of the types. So here I'm going to have basically an array of just the name of my types, and I know which folder. So from here, I'm doing promise all. The reason why I'm doing promise all is I want to execute the CLI in parallel. So then it's going to be faster. So I'm going to do type maps. Types, again, comes from read_dir_sync. And with that, I'm going to call the CLI. That's pretty much, in case there is some problems there, I'm going to notify to the developer, and obviously we'll pause the execution. And if everything was good, then it's going to say, okay, validator created. That's pretty much. So what is the problem with this implementation? Maybe you already noticed it. The main problem is that it will run once and it will stop, and that's it. And in case we add some modification to our Typescript, well, we have to start our server and restart it again, which in the beginning may not sound like a huge deal, but what happens if we have some kind of way to watch our files? And then I created a watch feature. So I'm using Chokidar. It's a Node.js application that allows you to watch for folders inside files and for specific events. And it provides this function watch. So it actually wasn't that complicated. I'm just watching the dir. And in case someone add a new file or change a file, it's going to call generate validator. And then here I using regex to ignore all the validator extensions, like the files that ends in the same validator extensions, which is .validator.ts. So this is amazing because now our types and validators are in sync, and every time I make any modification, they will be automatically generated. And this function, by the way, is going to be executed for each file individually. So in the end, at the beginning, it's going to run in parallel. So in case someone changed one file, it's not going to generate all of them. It's going to just generate the first one or the one that got changed. So my experience with this approach, in the past month, I will say, I started to work in a project called Open Source Project Dashboard. And it's a dashboard to provide a quick overview of open source project in GitHub. As I say, I'm an open source enthusiast, so I'm maintainer of a couple of projects. And it was a problem for me to keeping control the amount of PRs and the amount of issues that I do have. So this is a demo that I should load. There we go. So this is the project. It's quite straightforward. It provides you a quick overview of all your projects, all the issues, and all the pull requests that you have pending to fix. This is the projects that you can customize inside the configuration. And for example, these are all my open source projects that I'm interested in maintaining and keeping up to date. And all this information is coming from the settings that the user have. So these settings they are coming from GitHub Gist. So in the end, you actually can start using the tool today. It's deployed. It's there. It's in the GitHub that I showed before. And basically, you log in with GitHub. You give some basic permission to read access, then you need to define your information inside this GitHub gist. Has to follow the only condition that it has to be called open source configuration. All this information is inside the GitHub repository right here, so no worries. And then here you define the name of the projects and then the threshold. So the name of a project is very straightforward. Is which projects do you want to monitor? And then the threshold are in case you want to set some kind of warnings or say, okay, if I have more than 10 PRs, then notify me or tell me that something is wrong. And that's why my issues here are 5. And then here the color is in red, and then expected threshold is overpassed. Please take an action. I have to do that after, but yeah. So that's pretty much what the project does. It's fully built in TypeScript, and it's using GroupMed as a design system. And lastly, it's using the GraphQL API of GitHub to retrieve the data from them. So that's pretty much the stack. And then let's see the application flow. So in a nutshell, basically first I'm getting the gist information from the user from GitHub gist. Then with that information, I'm fetching the project. So with all the names, I'm going again to the GitHub API, getting all the IDs, the stars, the pull requests, everything from the name of the projects. And then I'm comparing the thresholds against the project information. So that's pretty much. And actually, the last part, in case you don't want to use a threshold, it will be optional. So again, at the beginning of my talk, I said, what are the things that do I need to validate? And I said, okay, external sources, right? So what are the external sources in this case? So the first one is the data coming from the GitHub API. And in this case, every time I ask for the projects, I will have to validate it. Normally in GraphQL servers, we don't have this kind of problem. That is not that normal, but it may happen that they do some kind of changes in the GitHub API, and then my application will crash. And then now the second one is the content from GitHub gist. So if you think about it, the content of the gist is like a file, and people can write down the JSON. First of all, can write an invalid JSON, can write down JSON which doesn't match with the structure I'm thinking of, or basically can even don't have anything related to a JSON file. It can be JavaScript, and then it will obviously fail. So I have to validate that. So relevant types for this task. We have the settings type. So settings are the thing used for the configuration. So here we have projects, which is a string of projects, and this has to be mandatory, otherwise the project doesn't make sense. Then threshold is optional, and threshold at the moment has pull requests and issues. Then the other one is the project. So project is the information about each of the project. So we have ID, URL, name of the project, pull requests, vulnerabilities, issues. They're all countable. So countable means that it's an object which has total count in order to know how many pull requests I have or how many issues. And then finally, we have stargazers, which is the people that send you a star for the project. And this also has total counts and also have nodes. And then nodes are stargazers, which has ID, name, and avatar URL. So how does it work to validate this information? So as I said before, I'm using the GraphQL API. So, here I'm importing my validator file. Here I'm using the GraphQL API. I'm using use query from Apollo. I didn't write down the query here because otherwise it was going to be too long. But yeah, basically I'm sending the name of the gist, which I had to get from before. And if basically the name is not there, I'm skipping it. So is the query is ready? So this function basically check if it is not loading or if there was no errors. So then the query is ready, has some data. So from there, I'm getting the GIS file, and then from the GIS file, I'm getting the GIS content, parsing it to JSON, and then with this content, it's actually raw. It's something that came from the JSON parse, and then I'm validating it. And at this moment, I'm just returning as an output inside here. So then what happened if there was some issue in the middle? So I'm alternating the error of Apollo in order to say, okay, invalid settings error, because basically there was no network error at the moment, but there was an error when validating the object. So that's for guest. For project, it's more or less the same. So we have, again, validate project. Then we have our function use project data query, which take the projects. This is the array of the project with names. And then with that, I'm using use query, where I'm sending the projects, and then I'm skipping it basically in case there is no projects, because there's no need to fetch if I don't have any projects to look for. Then if the query is ready, then I'm iterating on it. So here I need to do some kind of tricky parsing between the names. But ideally, this function is returning me the projects inside the repository query data. That's it, given the ID of the project. That's more or less to summarize it. I'm filtering the projects that didn't exist because maybe the user decided to write down a string which is not valid or doesn't exist in GitHub. So by doing filter Boolean, it's going to remove all the undefined or in this case, if the key doesn't exist in data, it's going to remove it from the array. And then finally, I'm validating the project using my validator and returning it as an output of the function. Then what happened if, again, something was wrong inside the validator? Then basically, again, returning the new Apollo error, saying invalid projects error. That's pretty much. So this is the way that I'm using this approach in my open source project. And I think it's very, very flexible. These are basically 2 examples that I'm using. I have one more, but I decided not to include it because it looks more or less the same, but I think you got the idea. And then let's do a quick recap. So what do we learn today? So in a way, today I show you 3 different approaches to accomplish the same goal, to basically validate external sources data. We have manual or using a library or dynamic types. So let's compare it first with no new syntax added. So in the manual, as we saw before, there is nothing there. There's just JavaScript or plain Typescript. So that's amazing. We don't need to learn anything new. With the library, sadly, we had to go to the documentation website to check how to do this. And it can be super frustrating. With the dynamic types, we are just using Typescript, which is amazing, right? We don't need to learn something new. In case we want to create these fancy validators, well, it's up to us, but yeah, like originally, we don't have to. Then validators and types in sync. In the manual, it's totally impossible to do that. In case we add a new type inside our types, a new property inside our types, we have to go to the manual and add it too. There is actually kind of, we can generate this validator manually, but I think it's going to be super hacky. The library, as I mentioned before, there is a way to inverse the order and generate the types given the validators. So that's why I decided to put a question mark, because it's doable. Then dynamic types, as I mentioned before, they're super in sync, especially with the watch version. There is no way that they can be out of sync. And obviously, if we're using the pre-commands too. And the final one is standardization. So with the manual, there is no standardization. So basically, what I mean is any developer can write down their own versions of functions the way they would like to. Again, how to check for the length on an array. There's like 6 different ways in JavaScript to do it. So that's bad for a big code base when we're working with several people, because it's going to turn out super opinionated. And yeah, it's a bad practice, I would say. With the library, it's cool because then we say, okay, how to check the length of an array? Oh, there is only this way with this property. Cool, finished, done. And then the last one with dynamic types is, as we're using AGV, and under the hood, we also have the standardization, which is actually pretty sweet. So just to close, I just want to leave you with this quote: validate more with less. I think this method is super effortless. And if you have some time and you're working with TypeScript codebase and you're having these issues, I encourage you to give it a try. So thank you for listening. Here you can find the links of the slides. And there are some references: AGV, TypeScript Validator, and the open source project. And if there are any questions, I will be in the QA panel.
Thank you so much.